Lesson 5, decimal points in products. Let's look at how products are in decimals. So our goal for today is I can use place value and fractions to reason about multiplication of decimals. So make sure you have today's date, your I can, page number, and you're ready to move on. All right, let's do some multiplying by 10 real fast here. Which of these equations has the largest number in x? Well, it's going to be this one, isn't it? Because the way we know that is whatever goes here, you multiply by 10, gives us our product. Well, the reason why this has to be the largest is that if we just look at the products, we can see that this has 810, so this has to be the largest one. They all use the same digits, but the value of each is different. How many times is the size of 81 hundredths is 810? So comparing that 81 hundredths all the way to the 810. It's 1,000 times different, right? Or 10 to the third power. Oops, put that in the wrong spot. Because think about it. This 8 is in the tenths and ends up in the hundredths, so it would have to go once, twice, 3 moves, and the only way to do that is to multiply by 1,000 to keep those digits the same. Okay. All right, now let's look at some powers of 10 with some fractions. Take a look at all of these. What would be the product of each of these? Yeah, 250 times 1/10 would get us 25 and 0/10, or you think of it as just 25, right? What about here? Yeah, 25 100ths, which is the same as 25 tenths, or 2 and 5 tenths. What about here? Yeah, 4 and 8 tenths. This would be 48 hundredths. So if we think about it, what's going to happen here with the 720 divided by, or times 1/10 and 720 times 100th? Yeah, they're still both going to have all the same digits, right? Here, since we're multiplying by 1/10, we're going to end up making this to 72, because this 1/10 like this represents a fraction 1/10. Same thing here. Well, similar, not the same thing. That 1/100th represents the 1/100, which means our decimal goes here, and it's 7 2/10. So what do we get on these? 36 times 1/10 is 3 6/10. 24 5/10 times 1/10, 2 45 hundredths. 1 8/10 times 1/10 gets us 18 hundredths. Because if you think about it, like, let's specifically look at this one. We've got 18 tenths, right? Because even though this is 1 and 8/10, we could think of it all together as 18 tenths. And we're multiplying it times 1/10. So 18 times 1 is still 18. 10 times 10 is 100. So now we have 18 over 100, which gets us that 1800ths. What about here? Yeah, this is going to be 54 times 1/100th, which gets you 54 hundredths, which gets us 54 hundredths as a decimal. Same thing again here. We have 92 tenths. It's one of the ways we can think of it. We have 1/100. I'm sorry, yeah, 1/100 gives us 92 thousandths, or 92 thousandths as a decimal. Let me rewrite that since I got some. Blast it. Oh, thousandths, not hundreds. There we go. Jada says if you multiply a number by 1/1000th, the decimal point of the number moves 3 places to the left. Does that make sense? Well, think about it. On each of these that were 1/10, the decimal place really only moved 1 place to the left, didn't it? And then when we did by 100th, it moved 2 places to the left. So what she says makes sense. And the reason why that makes sense is that we're moving by powers of 10. So what's happening is when we're multiplying by 1/10, we're actually moving all these digits down a place value in the tenths. Here we're multiplying by 100th, we're moving each of them 2 place values smaller. So here, when we multiply by 1,000, that would give us the same thing, that we would move it by 3 place values smaller. So how does the size of the product compare to the size of the factor when the factor is multiplied by 1/10? Yeah, it ends up all the digits go 1 place value smaller. What about here when we're talking about by 100th? Again, same thing. All the digits go place value smaller. In this case, it's going to be 2 place values smaller. What's 750 times 1/10? Or 750 times 1/100th? Yeah, we're going to have 75 for this first one. Yep. And 7 5/10 or 7 50 hundredths here. How do I know so? Well, again, this is multiplying by 1/10. We're basically dividing by 10. We're making all those digits move 1 place smaller. Here, we're doing the same thing, except that it's 2 places smaller. Oops. All right, let's do a little more digging with powers of 10. So, question here is, which of these would be equivalent to 6/10 times 5/10? Six times 1/10 times 5 times 1/10, would that be the same? Yeah. Why? Because this is basically just taking and separating those two things. It's still putting all the same things there. What about this one? Yeah, this piece right here where the 100th is, that is what throws it off. What about this one? Again, this is just, these are both say tenths. It's just written as a fraction. Value-wise, it's going to be the same. What about here? Yeah, no. We've got 1,000th, we've got 100th. Both of those are going to make these digits go to a much smaller value than they are currently. What about E? Yeah, again, we've got something that's going to make it go much smaller in value than what our original one was. What about here? Yeah, it's multiplication. As long as we're using the same things, it doesn't matter the order as long as all of it's multiplication and we're using all of the same way. What about this one? Yeah, that's definitely it too. This is just rewriting what's here, but as fractions. So what do we get when we multiply 6/10 times 5/10? Well, we get 30, right? 6 times 5 is 30. We're talking about tenths times tenths. So we end up with 30 hundredths. So we still get the same place values. It's just that now, or the same digits. It's just in a different place value based on what we're using to multiply by. All right. So wrapping up here, writing decimals in fraction form can help us determine the number of decimal places that a product will have. So we could think of this as 4/10 times 7 10,000ths. We can also think of this 4 as being 4/10, right? And the 7 as 7 10,000ths. So we get our 28, but then we're going to end up moving this to the 100,000ths place. Because of the place value that it is all the way over to the right. And so thinking about the fractional piece here is, that's why we talked about before about how multiplying fractions that are powers of 10 can make a big difference as far as value. What about here? Which of these is going to have more places to the right? The 300ths times 1,000th or 3/10 times 10,000ths? They actually are both going to have the same, right? Because both of them are going to have 3. We've got 1, 2, 3, 4, 5 places to the right here. We've got 1, 2, 3, 4, 5 places to the right here. So actually, even though we've moved things around, we basically took, we're going to get 300,000ths. Because think about it. Here we're talking about 3 over 100. This is 1 over 1,000. Here we're talking about 3 over 1/10. Here we're talking about 1 over 10,000ths. So any way you look at it, we're still going to end up with the same bunch of digits that for a denominator. And that's why the decimal is going to actually have the same in both cases. All right, so that's it for today with reasoning with multiplication. Thanks for watching.